Sabic IP adına Ürün Pazarlama Müdürü Sayın Hans-Otto Schlothauer kürsüye gelecek ve elektrik ve aydınlatma pazarındaki zorluklar hakkında bizi bilgilendirecek. Buyurunuz.
Yeah, thank you to give me the opportunity to speak today about Sabic Innovative Plastics and about some opportunities from our side in the sustainable and in the green, let's say, green solution of future for plastic materials. I hope you are aware on Sabic Innovative Plastics. If not, I'd like to give you first a short introduction of Sabic and Sabic Innovative Plastics. Then I'd like to go to the environment and to plastic materials. What are toxic-free? What means it behind recycling? What is the recycling process? What is the opportunities there? And last but not least, I will give you some information about materials, which I think is also an opportunity for more saving materials because of better properties of the materials. First, as said, I'd like to give you a short overview about Sabic. So Sabic is a 40 billion company on the revenue side. We are, have more than 100 operations around the globe with more than 45 production facilities around the globe and more than 30,000 people, again, around the globe. So the company was established in the mid of the 70s in the last century, and behind Sabic stays Saudi Basic Industry Company or company. So that's the mother of us is a Saudi Arabian company, as you can see from the name. So what is Sabic Innovative Plastics? Sabic Innovative Plastics is one of the 6 business units of Sabic. So if I go from the left to the right, so we have in Sabic, we have chemicals, we have performance chemicals, we have metals, metallizers, and then 2 polymer companies. So one is the polymer companies for the bulk plastics, so like polyolefins, polyethylene, polypropylene, PVC, and polyesters. And the other one are we with Sabic Innovative Plastics as a new, let's say, daughter of Sabic. We have the engineering thermoplastic materials, and maybe you are aware on GE Plastics. So was GE Plastics 4 years ago, and we are sold 4 years ago to Sabic, and now under the name Sabic Innovative Plastics, with well-known materials like Lexan, Noryl, Valox, Ultem, and. So as said, from the environmental and from the plastic view, I'd like to give you some information about the trends in the market, about regulations, what means this with the regulations, what means toxic-free for us, what means recycling of the material, and a little bit simplified recycling process, how we see and how we proceed this. So from the global mega trends, I think it's not a long time ago this year, we reached 7 billion people on the world, though there's an expectation that this will increase up to 9 billion in the next 30 to 40 years. So there will be more and more demand for materials, there will be more and more demand from the middle class in the environment to get more parts, more applications, so that means there's a big demand also from materials and not only for plastics, of course. From the basic material, so from the oil side, so the prices are around $100 per barrel in the moment, or even higher than $100 in the moment. So the expectations there is that this will growing up to 150 and even more. So we have to think about how we can use the material in a better way, the oil in a better way to take care on the environment side too. So if you look for the plastic consumption around the world, in the moment are used 300 million tons of plastic material. So that's not only technical thermoplastics, of course, it's also the bulk materials, and mainly the bulk materials, I have to say. So the expectations there is that this will be growing in the next 30 years up to 600 million tons. So it will be double in the next 30 years. Again, this is something where we have to take account on what will be the future in plastics and how can we survive in this industry or in this environment there. So with all these consumptions, what is the reason behind this? As said, the middle class will demand more materials, the middle class will demand more TVs, more mobile phones, more cars, and as an example, in the moment around the globe will be produced around 800 million cars. So the expectations there is in the next 30 years, this will be grow up to 3 billion cars. So more than 3 times more, even nearly 4 times more cars will be produced in the next 30 years. So again, we have to think about how we can use and reuse plastic materials in the future. And with what we already use in the moment, we already use more of materials, more of from the environment as the Earth can deliver for the future. So we have to think again there. If you go further in the way we do it in the moment, we need more or less, I like to say, 3 times the globe from the material perspective side. So regulations and standards. In the last, I like to say, in the last 10 years, you see a lot of legislations and standards coming on stream, like RoHS, WEEE. You have now REACH in several years, and all of them are linked in the end to be more environmental friendly, to don't use bromine flame retardant systems, for example. In the end, all looking more and more for more green or more environmental friendly solutions. You have the NGOs like Greenpeace who are also forcing us to think about the material use and how we produce and how we use the plastic materials. You see also that the OEMs like Osram or Canon, Nokia, they're also demanding materials which are more green, which are more environmental friendly. So that's again a step further to be more green and to think more about environmental friendly materials. And last not least, you have these TCOs, you have since several years now the EPEAT, which are asking also again for more environmental friendly solutions. So to complete this on one word, everybody is looking for more green, for more environmental friendly materials. So if you look for the flame retardant systems, so as say WEEE, RoHS, they all are linked or all requested to think more about the flame retardant systems, for example. They also think about don't use heavy metals like lead, don't use cadmium, and all the things around. And as also say the customers, the OEMs asking for more, so they're even asking for not to use deca PDEs, for example, so not to use brome additives at all. And what means is in the end, everybody's asking for flame retardant systems without halogens. So, and that's one of the reasons we in Sabic Innovative Plastics decided already, I think since 5 or 6, 7 years ago, we will only develop new materials which are halogen-free. So we don't use phosphorus, we don't use bromine, flame retardant systems for our new materials. So from the simplified recycling process, if you look to the bottom left side, there you see this oil barrels there. So if all of on the plastic side starts, let's say, with oil, yeah? With oil, then you produce your materials in the chemical plant, you compound the materials in the chemical plant, and in the chemical plant, in the compounding plant, there's already, I like to say, a cycle of reuse the materials which are the scrap during the production. So that's more or less covered. If you then use the material as a laptop or as a TV, as a car, there's no real good cycle to get the material back for reproduction, for recycling the material, for reuse the materials in whatever the way will be for recycling. So we have to think about how we can get the material back to us as a resin supplier or back to the chemical plants. So on the moment, more than 90% of the plastic used in the world will be landfilled or will be burned. Only below 10% will be recycled. So it's very limited amount of materials which in the moment comes back for recycling the material. So that's also something we have to think about, and everybody in this room have to think about how we can do this better in the future. And from this process, how to recycle materials, there are well-known processes on the bottom side, so the blue highlighted ones there. So if you see about this 10% which are recycled, a lot of these materials will be normally recycled by regrind the material. So first select the material, translate it or separate it into different material groups, and then it will be regrinded and reused with virgin materials for new post-consumer recycling materials, for example. The disadvantage of this is that normally, because of the history of the material, and you don't know the history of the material, and you also, because of the regrinding, because of the recompounding, all the heat history, these materials normally have less properties as a virgin material. So it will be in the end a downgrading of the material use. Another option is, and we heard it already several times today, just the speaker before me, is, for example, PET. PET is a material which are used mostly in the world for packaging. But it will be also used in packaging for water bottles. So all of you have water bottles in front of you. This material is PET. So we collected PET water bottles, and then we regrinded this in another way. It's not regrinding it, we do it in a chemical process. So we bring the material back to the monomers, I like to say, and make out of the monomers new material. And instead of PET, we make out of it BBT, so polybutylene terephthalate, which is also very well-known material, for example, in the electrical industry. So the idea of this is that this material then will be much, much better in the property side. So it don't lose the properties as for regrinding, which I like to show you on the next page. The other advantage, besides that you don't lose the properties, is that you use less energy. So the energy reductions there will be 47%. So more or less a half of the energy we can save in this way if you collect PET bottles, bring it back in a chemical way to the monomers and make out PBT in this case. So nearly 50% we can reduce the amount of energy we use. And not only we reduce the energy consumption, we also reduce the CO2, so the carbon footprint, by around a third of the production. So that's also helpful for, let's say, for the environment side. And as said, the big difference is that with this way to reuse the material on the chemical way, is that the properties of the material are more or less the same as the virgin material. And if you have a lot of opportunities there to use this material, you can use it straight as it is from the chemical processor side. You can also use it together with post-consumer recycling materials if the properties from your side is not needed in this way as it is for a virgin material. You can blend it with PC, with polycarbonate, to have a PBT-PC blend. And that is the reason, I don't have a slide here, that we have a bunch of different materials which is called Valox IQ or Xeno IQ, so PBT-PC blend, or Valox IQ PBT blends, which are flame retardant, halogen-free, which are without flame retardant system if it's good enough for your application. And we have a bunch of different materials, as said, with glass fiber, without glass fibers, which fulfill, even with a UL card, so with a yellow card for the American market, for example, the needs you have maybe for your application.